Hello everyone, welcome to series lectures of Basic Electronics, myself Heming Satvara, and today we are going to discuss about transistor as a switch. It is one of the transistors application. First application we have seen in our previous lecture, that was transistor as an amplifier. Now in this lecture we are discussing about its second application, transistor as a switch. So let us discuss about basics of transistor as a switch. We all know that transistor has four regions of operation, in which active region, cutoff region and saturation regions are commonly used. I said four regions of operation, that means active forward and active reverse region. So there are four regions of operation, but here in this chapter we are discussing only active forward region. Transistor works in active region when it worked as an amplifier. Be specific, active forward region. When it is worked as a switch, it should be in cutoff and saturation regions. So here switch is a very useful and important application of transistors. In most digital ICs, transistors will work as a switch to make power consumption very low. So here we can see this is the biasing of NPN transistor. So for transistor as a switch, transistor should be work in cutoff region and saturation region. If transistor is in cutoff region, then B junction and CB junction should be in reverse biased, and its application is open switch, as we can see here. In second region of operation, if it is in saturation region, then base emitter junction and collector base junction should be in forward bias, and its application is closed switch. That means in order to use transistor as a switch, it should be operated in cutoff region and saturation region. So here let us discuss with its first case, which is known as cutoff region. So here we can see this is the transistor in cutoff region operation. If operating condition of transistor are zero input base, that means IB 0, zero output collector current, that means IC is equal to 0, and maximum voltage, that means VCE, across the transistor, which results in a large depletion region and current flowing through the device is 0. Therefore the transistor is fully off. Here we can see the operation in step-by-step region. If Vin is equal to 0, that means your input voltage is equal to 0. We can say your input is directly connected with the ground. So your flow of IB, it is also 0, because your input is equal to 0. Then your IB, that means base current, is equal to 0. If your base current is equal to 0, then your IC is equal to 0, because IC is your output current, or we can say this is the collector current. So it is also 0. Then voltage drop across the VRC is equal to 0. If IC is equal to 0, that means across that resistor voltage drop should be 0. If voltage drop is equal to 0, that means your VCC is equal to output voltage VO is equal to 1. Be precise, we can understand from this circuit diagram. Here we can see this is the circuit diagram of transistor as a switch. Vin, where we can put input waveform, and VO we can get output waveform. So here if we applied Vin is equal to 0, that means your IB, here we can see base current is equal to 0. If your input current is equal to 0, that means your output current IC is equal to 0. If your output current IC is equal to 0, that means across this RC, this is the collector resistance, across this RC voltage drop should be 0. If your voltage drop across this resistor is equal to 0, that means at your output voltage you will find the value of VCC. If I applied VCC is equal to 5 voltage, that means at your output voltage you will get 5 voltage. So that means here this transistor becomes off. So here we can see its equivalent circuit like this. So transistor becomes off. That means here resistance is very high. So your output voltage is equal to VCC is equal to VCE is equal to 1. So for the cutoff region you will get 1 when you apply 0. Now next, this is the second region, or we can say saturation region. Here transistor in saturation region operation. Now transistor will be biased, so maximum amount of current is applied, resulting in maximum collector current. Now it is totally inverse of the case number 1. In this case, in case number 2, we applied V input. If we applied V input, that means your IB goes flow. If your IB flows, that means your IC flow. If your IC flow, that means voltage drop across that particular resistance will be cited. Here we can see if we applied V in is any value, so IB flows. If IB flows, that means IC becomes saturated IC. If IC is equal to IC saturated, that means VRC is not equal to 0. That means there will be a voltage drop across that collector resistance. That means if there is a voltage drop present, VCC is not equal to your output voltage. That means VCE is equal to VO is equal to, we can say, 0. So be specific. We can understand from this circuit diagram. Here this is the saturation region. If we apply V in input voltage, that means your IB flows and IC flows as well. So here we can see its equivalent circuit of this saturation region like this. Here your transistor becomes on because across this transistor you will find lower resistance and you will get VO is equal to VCE is equal to 0. That means it is the inversion. If you applied 1 and you will get 0. Here we can understand through this input to output waveform for transistor as a switch. Here we can see above, this is the input voltage and below shows output voltage, and we applied here square wave because as a switch we can understand through this square wave, because square wave has a two value 0 or 1, whereas in sine wave you will find more different values. So here if we applied 0 value, that means this is the input. If your input is equal to 0, that means you will get 1 in your output voltage like this. Now this is the square wave. In next case, if you entered 1 as a input, so this is your 1, at this time you will get your 0. Be precise, this is not exactly 0, it depends on the resistor and many more factors, so it is nearly equal to 0. Then again repeat, if you entered here 0 in your input value, at this time you will get your output is equal to 1. Now here first case shows that transistor is in off situation, and second case indicates transistor is in on condition, and similarly in case number 3 it repeats itself, case number 1 and 2. So here is the applications of transistors: logic circuits, temperature controllers, timers, SMPS and UPS, and we can also use in stepper motor controllers. So these are the applications of transistor. So transistor as a switch we can use in this different types of controllers or circuits. That's all for today's lecture. If you have any problem related to this topic, you can mail me on this email address. That's all for today. Keep learning, keep reading. We will see you soon in next coming lecture. Thank you.